In section 20, we're looking at applications of systems of equations. So again, we're still going to use our same methods of elimination or substitution, or if necessary, we can graph to solve these. But now we're trying to pick out the system of equations from the context of the problem. So the first problem we're going to look at, it says, in preparation for a barbecue, Crystal goes to the store to buy burgers and hot dogs to grill. So let B represent the cost of a package of burgers. That's key information there. They're defining what the variables should be. And then H represents the number of hot dogs, or the cost of a package of hot dogs. On her first trip, so we're at the first bullet point now, Crystal buys one package of each for a total of $7. One package of burgers, one package of hot dogs, and it costs her $7. All right, more people show up than she expected. She's got to go back to the store, so we get to bullet point 2. On her second trip, Crystal buys 4 packages of burgers and 3 packages of hot dogs for a total of $26. Question 1 says, write an equation that represents Crystal's first trip to the store. So on her first trip, again, she's buying 1 package of burgers, that's B, and 1 package of hot dogs, that's H, and she's spending a total of $7 on that first trip. So that's this guy right here, B plus H equals 7. Question 2 says, write an equation that represents Crystal's second trip to the store. So now we're looking at this one here. So on her second trip, 4 packages of burgers, 4B. 3 packages of hot dogs, 3H. Total of $26, so equals $26. Now at this point we have a choice. It says in question 3, which method would you prefer to use to solve the system of equations, and explain your choice. I chose elimination because the variables are on both sides, or on the same side of both equations. However, you could fairly easily, I think, use substitution. Take one of these equations, solve for either B or H, and then substitute it. So if I'm using elimination, I'm going to pick a variable to get rid of. I decided to get rid of the B's, just because, no reason in particular. I multiplied top equation by -4 and brought it down here, giving me -4B minus 4H equals -28. When I combine these equations, the B's are going to cancel, and the H's, I'm going to have -H. 26 and -28 is -2, so H is 2. And that is the cost of 1 package of hot dogs. To find the burgers, I can take the hot dogs and plug it in here, or any equation really, but this one seemed to be the easiest. And I'll have B plus 2 equals 7, so the burgers cost $5 per package. In our second situation, we have Adrian and Brienne work at an animal clinic. Let A represent Adrian's years of experience and B represent Brienne's years of experience. So the first part of this says that Adrian and Brienne have a total of 54 years of experience. This will be in question number 5. Question 5 says write an equation that represents the total years of experience between them. So A plus B has to equal 54 because they have 54 total, add them up, years of experience. The challenging one, though, is question 6. It says write an equation that represents the second relationship between their years of experience. So here, we're going to kind of read it and pick out the key information as we go along. So the number of years that Adrian has worked, that's A, is, and then this is an equal sign, 18 fewer. So we're taking 18 away from something, and we're taking it away from twice Brienne's experience. So taking 18 away from 2B minus 18. In question 7, which method are we going to use? Again, I'm going to use substitution in this case, and you have a choice, but the reason I'm going to do that is in the second equation, the 2B minus 18, A is already by itself. So that would be a fairly easy thing to substitute. You could use elimination, but I think it's going to be a little bit more challenging to do that. So I took that A equals 2B minus 18, and I substituted into the first equation where I saw A, so replaced it. 2B minus 18 plus B equals 54, and I solve for B to get 24. Once I have 24, I can take that and plug it back into here to find out A. 2 times 24 minus 18 gives me 30. So Brienne's been working at the clinic for 24 years, and Adrian has been working for 30 years. All right, third one I think is one of the more challenging ones here because there's a lot going on in this question. Mr. Lincoln wants to win the Pennies for Patience title at his school. He needs to know how many of each type of coin he has. So here's our first equation, or first situation, I guess. He has a box of 716 coins, including pennies, nickels, dimes, and quarters. He knows he has 255 pennies and 89 nickels. All of a sudden, I know these two pieces of information right here. That changes things a little bit for us. The total value of the coins is $82. So what variables will you use in this scenario? Well, I could technically use four variables, P, N, D, and Q, except I already know how many pennies and nickels we have. So it's not really a variable. It's just using that piece of information. So my setup here, all four coins together have to add up to 716. So I take my pennies, my nickels, my dimes, and quarters, and that has to equal 716. That's a perfectly valid equation, however, probably not really easy to work with. So what I did next is I took these two numbers here, 255 and 89, added them up, and subtracted from 716. So now I'm left with, on this side, D plus Q, and on this side I've got 372. In the next part, way off on another page here. All right, here we go. In the next one, write an equation that represents the total value of coins that Mr. Lincoln has collected. So he's collected $82. We know that information right here, and that's from that piece right there. We now need to know how much are the pennies worth, the nickels, the dimes, and the quarters. How much total do we have for that? So I can take the number of pennies and multiply by what they are. Pennies are worth $0.01. The nickels, I did 89 times 0.05. The dimes, which I don't know, times 0.1, 10 cents. And then the quarters are 0.25, so Q times 0.25. All that added up has to equal 82. Then I multiplied these guys out, and I combined these like terms, so I got 7 for this, brought it over with the 82 to get 75. I just brought down these numbers here. Those are my two equations. Now, again, we have a choice. What do we want to use? I decided to use substitution, and I believe I said I'm going to get D by itself. And yep, that's what I did. Solve the system of equations to determine how many of each type of coin Mr. Lincoln has collected. So again, these are two equations rewritten down here so that we can keep track of the information. So I solved the first one, D equals 372 minus Q. I take that D and I plug it into here. 0.1 times 372 minus Q, that's what it is, plus 0.25Q equals $75. Distribute the 0.1, so that's what I get here. Add my like terms, that's this step, and bring this 37.2 over to get 37.8. When I divide by 0.15, I get Q is 252, and I can use that to find out the number of dimes. 372 minus 252 would give me 120 dimes. I want to go back up to number 11 real quick. There's another way to approach this. You could write this in terms of cents. So if you wrote this in terms of cents, a penny is worth 1 cent, so you'd have 255 times 1, plus 89, nickels are worth 5 cents, so plus 5, plus dimes are worth 10, so 10D, quarters are worth 25, so 25Q. But that changes this number here because this number is dollars. So if we have $82, that really means we have 8,200 cents. So now this system right here, the numbers are big, but you're not dealing with the decimal issue. So again, your call on what you want to do. Think of it the easiest way that makes sense for you. And our last question here is about buying some fruit at a store, a Jewel. Kevin buys 2 cantaloupes, 1 pineapple, 1 watermelon. The total is $10 for all those things. Pat buys 2 cantaloupes, 3 pineapples, and 2 watermelons for $18.50. And we know that a cantaloupe is going to cost $2. So we're not going to use that as a variable because we already know it. So we're going to use P for pineapple, the cost of a pineapple, and W for the cost of a watermelon. Our two equations, Kevin has 2 cantaloupes at $2 a piece, plus 1 pineapple, plus 1 watermelon, and it's $10. I went ahead and rearranged this to make it a little bit easier, P plus W equals 6. I do the same thing down here for this question, number 16. Write an equation that represents the food that Pat bought. Pat bought 2 cantaloupes, 3 pineapples, 2 watermelons, and spent $18.50. Again, bring that 4 over, 3P plus 2W equals $14.50, and go from there. And what I originally had in this problem is I completely forgot about the cantaloupes when I set up my equations. So I was going ahead and solving it, and then I ran into a big issue that I found out that the watermelon was worth a negative dollar amount. So if I went to go to the store and buy the watermelon, they would pay me to take it. Would that be nice? But that's not realistic. It doesn't make much sense. So we're working the equations that we have here. P plus W equals 6, and 3P plus 2W equals $14.50. I decided to eliminate the W's, so I multiplied the top equation by -2. Negative 2P minus 2W equals -12, and add straight down to get 1P equals 250. Take that 250, plug it in here to find out what W is. So 250 plus W equals 6, and then that ends up giving me $3.50.